attracting one. Stable limit cycles are very important scientifically because a system with stable limit cycle can exhibit self-sustained oscillations. That is, self-sustained oscillations. Meaning that these systems oscillate in the absence of external periodic forcing. Most of the biological processes of interest are of this kind, like beating of a heart, periodic firing of a pacemaker neuron, daily rhythms in human body and hormone secretion, etc. Now coming to the second case, unstable limit cycle. If the neighboring trajectories are repelled from the limit cycle, then it is an unstable limit cycle. That is, all the trajectories which are sufficiently close to the limit cycle diverge from the limit cycle as time approaches infinity. Now coming to the third case, that is half stable limit cycles. Half stable limit cycles are one which attract trajectories from inside and repel those on the outside, or vice versa. For instance, if you see this figure, you can see that all the trajectories from the outside are repelled by the limit cycle, while all the trajectories in the inside are attracted towards the limit cycle. The opposite case is also true. That is, the trajectories from the inside can be repelled by the limit cycle and the trajectories on the outside can be attracted by the limit cycle. In this case also, the limit cycle is called a half stable limit cycle. Okay, that is, if some trajectories which are sufficiently close to a cycle converge to that cycle as t tends to infinity and others diverge from that cycle, we call the cycle a half stable limit cycle or semi-stable limit cycle of the system. That is, semi-stable limit cycle. Now, having talked about closed loops in nonlinear systems, a question arises. That is, what about closed orbits in linear systems? The answer is, linear systems can also have oscillations that are closed orbits. However, we know that linearity implies if x of t is a solution, so is c into x of t, where c is a constant. This means that the amplitude of the oscillations is determined by the initial conditions, unlike the case of nonlinear systems. That's all for this lecture, and if you have any doubts, please feel free to ask in the comment sections. If you found the lecture useful, please like the video and also support us by subscribing to the channel. In the next video, we will discuss about Poincare-Bendixson theorem, which is used to check the existence of limit cycles. Thanks for watching and have a nice day.